would be simple harmonic motion, SHM, right? Periodic
Yeah.
motion, periodic motion, and simple harmonic motion. Now understand, what is a periodic motion? Understand that. A periodic motion is a motion. A periodic motion is a motion which repeats itself, which repeats itself after a fixed duration of time. Okay? Which repeats itself after a fixed duration of time. That is a periodic motion. You understand? Like,
Yeah.
for example, the rotation of Earth. So, rotation of Earth basically is an example of what? Rotation of Earth is
Yeah.
an example of periodic motion. Why? Because it is rotating and coming back to its position both all after 24 hours.
Yeah.
You understand? So, this is an
Yeah.
example of periodic motion. Revolution of planets, revolution of planets around the sun. So, basically, revolution of planets around the sun would be what? Would be the periodic motion. Like, for example, this is the sun, and all the planets are revolving around it. So periodic motion means that after every 365 days, like for Earth, if I talk about Earth, so Earth every
Mhm.
365 days come back to the same position, like because it is revolving. So the time for the revolution of the Earth to come back to the same point A after motion is called as a periodic motion. Are you understanding?
Yeah.
And after how much time is it repeating itself? After 365 and one fourth day. Are you understanding?
Yeah.
That means 365 days, full days, and 6 hours extra. Do you understand my point? So after this
Yeah.
much time, they are repeating itself. Anything other than that? What periodic motion could be? A periodic motion could be a person. Let's suppose I say that there is this wall and there is this time. So you understand. So on this particular axis, we have time, and on this particular axis, we have the distance. You understand?
Yeah.
So when we have the distance and when we have the time, I hope you're understanding what is happening right here. So just see. So time, this is going to be zero. Yes or no?
Yeah.
Right? So what is happening here? Just understand. When we are talking about the time, right? When we are talking about the time, so understand. Let's suppose this is a wall, and there is this ant. What is it doing? It is moving upward, reaching a certain height, falling back again. Then moving up the wall, same height, coming back again. Moving up the same height, coming back again. So this is what you exactly mean by the periodic motion. So how would I say that when the ant is wall like moving on the wall, obviously some time is being spent. So at t equals to 0, the ant was here. At t equals to
Mm-hmm.
1, the ant was here. At t equals to 2, the ant was here. At t equals to 3, the ant was here. Are you understanding?
Yeah.
What would that mean? That as the time is passing by, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 7 second, 8 second, 9 second, 10 second. So what is going to happen? That the person moves, takes 4 seconds to reach a certain height, again falls down. And the
Yeah.
falling is very instantaneous because that's very quick. So the time, that is obviously some time must be passing away to fall down, but that time is not measurable by the devices we have. So then the person does what? Then this ant again moves up, takes another 4 seconds. Right?
The graph, how would, if it is distance time graph, how is it going down?
One, two, three, four. Yeah. No, it is eight, those things. So this is going to be something like this. That's what I'm saying. It is not going to go down. It should have gone like this. This and this. This and this. It is actually a displacement time graph.
Okay.
It is actually a displacement time graph. You understand my point?
Yeah.
So in this example of displacement time graph, so basically this graph should actually have gone like this and this and this and this.
Yeah.
But you know what is happening? The ant is moving up the wall and falling down, moving up the wall and falling down, moving up the wall and falling down. Are you understanding?
Yeah.
So this kind of graph is also what? This kind of graph is also a periodic motion. Understood or not?
Yeah.
Like this. So this is also a periodic motion. Why?
So
Because it
can
is
we say
taking
that?
some time to repeat itself and it is repeating after a fixed interval of time.
So can we say that like if we see a graph and the
Now understand what other possibility could have been? It could have been a pendulum. So this is the mean position of the pendulum. X equals to 0, I will say this is the mean position of the pendulum. So if this is the mean position of the pendulum, what would that mean? Tell me. What would that mean? So this pendulum can go up till here, and then this pendulum is going to go up till here. You understand?
yeah,
Understand? So when this pendulum is going to go up till here and up till here, what is that going to mean? Tell me. So it is not, it is coming back to its mean position, going here,
yeah,
then coming back, and then going here. तो ये भी तो क्या हुआ? This is also going to be the mean position. This is also going to be the periodic motion. तो periodic motion exactly है क्या? Periodic motion एक वो motion है जो अपने आप को बार बार सेम टाइम के बाद रिपीट कर रहा है, विच इज रिपीटिंग इटसेल्फ आफ्टर अ फिक्स्ड इंटरवल ऑफ टाइम. आर यू अंडरस्टैंडिंग?
yeah.
वो कैसा भी मोशन हो सकता है, ठीक है, उसमें कोई हार्ड एंड फास्ट रूल नहीं है. इट कुड गो लाइक दिस एंड दिस, राइट? इट कुड गो लाइक दिस एंड दिस. इट कुड बी अ वेरी स्लाइट मूवमेंट, ऐसे भी हो सकता है, हल्का सा इधर गया फिर बीच में आया, फिर इधर गया फिर बीच में आया, फिर इधर गया फिर बीच में आया, एंड सो ऑन. समझ आ रही है बात?
Okay.
ठीक है. सो दिस इज पीरियोडिक मोशन. अच्छा, पीरियोडिक मोशन और कैसे हो सकता है? पीरियोडिक मोशन इस तरह से हो सकता है कि भाई एक बॉल है. सो दिस इज द ग्राउंड, और आपने क्या करा, इस ग्राउंड को, इस बॉल को आपने फेंका ऊपर की तरफ. तो बॉल ऊपर गई और वहां से फिर नीचे गिरी, फिर बॉल ऊपर गई, फिर वहां से फिर नीचे गिरी. अब वो बॉल जितना समय ऊपर जाने में लगा रही है, उतना ही समय वो नीचे आने में भी लगा रही है. तो उसका ग्राफ कैसे बनेगा? डिस्प्लेसमेंट तो फाइनली जीरो हो ही है ना उसकी, है ना? तो अगर वो बॉल मान लीजिए यहाँ से शुरू होती है, टी इक्वल टू जीरो से शुरू होती है, तो उसका कुछ डिस्प्लेसमेंट बढ़ता है और फिर नीचे गिरता है ना? फिर बढ़ता है, फिर घटता है. तो उसको गिरने में जितना समय लग रहा है, लाइक फॉर एग्जांपल उसको 3 सेकंड्स मान लीजिए, 1 2 3 4 सेकंड्स मान लीजिए, हाइट मैक्सिमम हाइट पे जाने पे लग रहे हैं, तो उसको 4 सेकंड्स नीचे आने पे भी लग रहे हैं. फिर
But
उसको
then why is the graph like up and down like that? Why is it not like the first graph?
या वही मैं बता रही हूँ. वहां पे क्या हो रहा है, वहां पे जो एंट है, एंट कैसा है, बहुत ही लाइट है ना, तो उसको एकदम से गिर जाएगा वो, तो उसका टाइम हम मेजर नहीं कर पाए. तो जब हम उसका टाइम मेजर नहीं कर पाए तो क्या हो रहा है मुझे बताओ. ये हाइट बहुत ऊंची थी, ये जो हाइट जिस पे बॉल गई ये बहुत ऊंची थी, वहां से ही गिर रही है. तो वहां पे हम टाइम मेजर कर पाए ना, नीचे गिरते वक्त का भी टाइम, और यहाँ ऊपर जाने वक्त का टाइम हम कैलकुलेट कर पाए. लेकिन यहाँ पे एंड क्या था, एक जरा सी दीवार थी, उस पर हल्का सा डिस्टेंस वो चढ़ता था और फिर गिर जाता था. तो नीचे गिरने का डिस्टेंस हम मेजर ही नहीं कर पाए, क्योंकि गिरा तो वो ग्रेविटी की वजह से तुरंत गिर गया, लेकिन चढ़ते समय उसको ग्रेविटी के अगेंस्ट धीरे 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 काम करना पड़ा. तो उसका ऊपर जाने का जो समय था, टाइम रिक्वायर्ड टू क्लाइंब द वॉल, वो हम मेजर कर पाए, लेकिन नीचे गिरने का टाइम हम मेजर नहीं कर पाए. ठीक है. हाँ,
I
अगर आप टाइम मेजर कर पा रहे हो तो वो ग्राफ बिल्कुल इसके जैसा दिखेगा जो मैंने यहाँ पे बनाया है. तो
I
अब
didn't get the diff.
एवरी पीरियोडिक मोशन has a fixed time period of repetition, has a fixed time period of repetition. You understand?
Yeah.
Second thing, What do we have in here? Every periodic motion has a fixed time period, right? Second point that we have to understand here is that in ideal conditions, we're going to study the periodic motion. So in ideal conditions, a motion can be periodic. A motion can be 100% periodic, assuming no loss of energy. Assuming no loss of energy. So that is the condition. Do you understand my point?
Yeah.
Right. Now let's discuss about a simple harmonic motion. So what is a simple harmonic motion? Simple harmonic motion is also called as oscillatory motion. Simple harmonic motion is also called as the oscillatory motion. Are you understanding?
Yeah.
Now, what do you understand by simple harmonic motion or oscillatory motion? Just understand. When we are talking about the simple harmonic motion, see, understand. Simple harmonic motion is a periodic motion only. Simple harmonic motion is a periodic motion only. But what is the difference? What is the difference? The difference is, the difference is, the difference is that in periodic motion there has to be a straight line motion only. It has to be a straight line motion only in the simple harmonic motion. You understand? So it could be forward, back and forth, up and down,
Okay.
right? So
That's
simple
it.
harmonic motion or oscillatory motion includes back and forth motion. This is also called as to and fro, back and forth.
So is simple harmonic motion a part, like a type of periodic motion?
Yes, because periodic motion could be circular. Periodic motion could be going up and coming down. You understand?
Yeah.
Periodic motion could be the rope could be moving up and down, up and down. This is all periodic motion because the time it is taking to occur is exactly same to repeat itself. But that is not a straight line motion. So
Okay. So
in
simple
straight
harmonic
line
motion
motion,
is straight.
this is the mean position, let's suppose x equals to 0. So what I do, I move forward. Along the same line, I come back. Then I go back. Then I come back. This straight line motion, and on the straight line only, I'm doing back and forth, up and down, up and down. You understand?
Yeah.
So this is called periodic motion. This is called oscillatory motion or simple harmonic motion. That is the point. Are you understanding the point?
Yes.
Understood? So now
Yeah.
basically when we have to understand periodic motion is vast. But we have to deal with only that straight line. We have to deal with only the straight line to and fro motion. Straight line to and fro motion. Understood or not?
Yeah.
You understand? And we have to
Yes.
study that, what is the equation. So understand sometimes, let's suppose we are talking about the pendulum. So we say that, the pendulum's motion is sort of SHM, but not over a large limit. If the pendulum is moving very small, like here.
Hmm.
So if this angle is very, very small, right? So it is moving left and left, and it is moving left a little bit here.
Hmm.
So when the pendulum is moving left and left, left and left, but not over a large distance, it is moving over not over a large distance. It is like this, here and here. So this could be considered as a straight line, a small straight
Yeah.
line. Are you understanding?
Yeah.
So that is the concept. That is the concept. So when we are talking about the simple harmonic motion or the oscillatory motion, so we can put certain circular motions as well under certain limits in the simple harmonic motion also. But understand, just remember there's a difference between to and fro, back and forth, all of them, up and down. These motions are all coming under the category of simple harmonic motion. Understood or not?
Yes.
Right? Now, understand. There's a term. Now, let's understand a little bit about circular motion because we're going to relate circular motion a little bit to the simple harmonic motion. Okay. So, how does it sort of work? Just understand. Just see. So, we have this circular motion. This is the circle, right? And we have the center of the circle. and we have a bob right here. Understood or not?
Yeah.
And we're going to push it. When we're going to push it, obviously this bob is going to move like in the circle. And we have pushed it so hard that it is going to take this full round, full circle it is going to make. Are you
Yeah.
understanding? So
Yeah.
obviously, after a period of time, this is going to come at its new position, which is the red position. So after some time t, the bob has come, has moved an angle theta upward, and at some time, let's suppose at 2 seconds, the bob has come at particular position b. You understand?
Yeah.
And t is going to be at 0. It was at the yellow position. And as the
Mm-hmm.
time passes by, obviously the bob is going to come at this green position, and the t
Yeah.
is going to be 4 seconds, let's suppose. And it is going to travel some more distance here, let's suppose some another theta from the starting position. Starting position is
Mm.
definitely the yellow position. So what am I saying? That after t equals to 0, it has moved to point B. At B point, from my starting position, which is my A point, it has moved
Mm-hmm.
up an angle theta. And this is
Yeah.
continuing. Are you understanding? So there would be a time then it is going to come at position, at the blue position, which is position H point, the highest point.
Yes.
And then it is going to come down because we have pushed it right here. We have pushed it harder. We have pushed the bob harder. Why? So that it can loop the loop. It can loop the loop.
Blue. Yeah.
Understood or not?
Yes.
Now, what is happening here? Just understand. So when it is coming down here, यहाँ से, when it is coming down here, here, you
Mm-hmm.
understand? So this is going to be again M point, let's suppose. And then finally, it is going to come back to its original position, which is at the yellow position. What I'm trying to
Yeah.
tell you that it is a periodic motion. It is a periodic motion. But now let's understand, if we have a scenario that if we are looking this particular bob from a certain perspective where I can see the shadow of the bob. So let's suppose this is the shadow of the bob. This is the shadow of the bob here. This is the shadow of the bob. This red portion ball. S. My original bob is the yellow ball. This is going to be my original bob. It's a little bit understanding concept, but once you understand it, it will be very easy for you to understand. This is the original bob, and
Mm-hmm.
we have S as the shadow of the bob. Understood or not?
Okay.
So when this bob is at its starting position, this is the starting point of the bob. So the shadow is right here. And I will say this is the mean position of the bob. This is the mean position of the shadow of bob. Can I say that?
Yeah.
Now understand, when the bob has moved little bit upward like this. So the shadow, if the bob is moving upward here, so the shadow definitely comes under this here. Are you understanding?
Yeah.
If the bob goes even higher here, the shadow comes here.
Correct.
And if the bob goes here at the green position finally, so the shadow goes here. Understood or not?
Right.
So where is the
Yeah.
shadow moving initially? The shadow is moving initially towards right. Yes or no?
Yeah.
Right? Any doubts in this?
No.
What is going to happen then? Then this bob is not stopping. This bob is moving here up. So when the bob
Yeah.
comes here, the shadow again comes back at this position.
Yes.
And then the bob goes even higher. So shadow goes here.
Yeah.
And then the bob goes again at the highest position. The shadow comes exactly at the mean position. Where is the shadow coming back? At the mean position.
Yeah.
Are you understanding?
Yes. So this is simple harmonic motion then.
Exactly. So shadow is performing simple harmonic motion because shadow is moving forward and backward. Forward and backward. You understand? Then when the
Yeah.
ball is coming down, the shadow is formed right here. When the bob is coming here, the shadow is formed here. And when the bob is coming here, what I'm trying to tell you that the shadow is not going beyond a certain limit. The shadow is limited only in this particular region. Only in this particular region, the shadow is limited. It cannot go beyond this distance. इतने ही distance में, in this distance only it is limiting itself. Are you understanding?
Yes.
And when it is coming back here, 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 the shadow is again coming back at these positions. The shadow moves here and comes back here. So the shadow is performing simple harmonic motion. Understood or not? Tell me.
Yes.
Right? This is the concept. Right? So what I'm trying
Yeah.
to tell you that we can obviously, because SHM, when I say SHM, somebody is performing SHM, that is my to and fro motion. To and
Mm-hmm.
fro motion. Obviously, you know, the person will be doing a periodic motion, no doubt about it. But in SHM, the person shall be moving along a straight line, and a periodic motion could be a circular motion as well. So basically, what makes this chapter a little bit difficult that we are trying to consider every periodic motion as an SHM, because somewhere down the line, either the shadow of the body undergoing periodic motion or anything, generally the shadow is going to perform SHM.
Yeah.
You understand my point?
Yeah.
Now understand what we're doing. Now let us suppose when we push the body, when we push this particular object. Now understand. So we are moving, we're talking about the motion of the body here. So this is the center. This is the
Yeah.
center. If this is the center, what is going to happen? Just tell me. So this is the bob. I have pushed
Mm.
it. Definitely the bob is going to move up with a certain velocity. So the bob, let's suppose, comes at the red point. The bob comes at the red point, moving an angle theta in t time. And if I say that,
Yeah.
so what is going to happen? Just understand. So the bob moves up with a certain speed and covers an angle theta and covers an angle theta in time t. Yes or no? Let's suppose it moves an angle 30 degrees in, let's suppose, 5 seconds. You understand?
Yeah.
So what would you say? That, ma'am, in 5 seconds, the bob is moving in such a way that it has covered 30 degrees and it
Correct.
has moved from point A to point B. So basically, in
Mm.
1 second, how much it is going to travel? 30 degrees over 5. That means its
5
speed is such that it is traveling 6 degrees per
per
second.
second.
Yes. So this degrees per second is called as the angular speed, because now I'm not telling you the distance or the kilometers or the meters. I'm telling you the degrees per second. So this shall be called as the angular speed. Understood or not?
Yeah.
Right? This is the angular speed. Any doubts in this?
No.
Okay. Now understand. So for example, so now this continues. So if I know the angular speed, now can you tell me that how much angle it would be traveling? So this angular speed I denote with omega. The angle
Yeah.
traveled I denote with theta. And the time I denote with t.
Correct.
You understand?
Yeah.
So now if you know the angular speed, and this is a fixed angular speed for a particular body undergoing circular motion, can I say one thing? Can I say one thing that, tell me after 12 seconds, where do you
Mm-hmm.
think the body would be? So you will say every second it is traveling 6 degrees. So, ma'am,
6 degrees.
after 12 seconds, it would have been away by 6 degrees
Stop.
into 12.
Yeah.
That means 72 degrees away from the starting position. Yes or no?
Yeah.
And if,
Yes.
if it is going to be 72 degrees away from the starting position, what does that mean? That it is going to be, this is 30, this is 90. So, ma'am, somewhere here. somewhere here at the blue bob, C position. So this must have been 72 degrees away from the starting position. I hope you're understanding,
Yes.
right? So can I say if I know omega and if I know time, so can I say omega into time shall give me the overall total theta traveled from the starting position?
Yes.
So what is omega t? Omega t, omega is my angular speed and t is my time. Understood or not?
Yes.
Got the concept?
Yeah.
All right.
Yes, got it.
Right. And this, if theta remains constant, if omega remains constant,
Mm-hmm.
if omega remains constant, so this is called as a uniform circular motion.
Motion.
It's
But
not
this circular motion is not simple harmonic motion, right?
no, no, it is a periodic motion.
It is a periodic
And
motion.
SHM is also periodic motion. So we are sort of relating to periodic motion basically.
Okay.
You understand my point?
Yes.
So this is basically the basic concept. First basic concept is this. Then, so if the body is moving upward and downward, it doesn't matter. It is traveling every second 6 degrees. Now, there is one more concept to this. Understand? So, for example,
Mm-hmm.
next point. So, these are small, small, small chunks that I'm discussing right now, and then I'm going to consolidate all of them. So, you have understood what is a periodic motion. What is
Yeah.
a periodic motion? You know basically what is an SHM or the oscillatory motion, which you call it as the to
Yeah.
and fro motion. You know
Yes.
what is angular displacement now? Angular displacement is theta.
Yeah.
You know what is angular velocity,
Yes.
which is omega. And you know what omega into time means, that is theta. Yes or no?
Yeah.
This
Yes.
much you have understood. And you have understood that, a body which is performing the circular motion, which is in itself a periodic motion. So its shadow would be doing an SHM, moving right and backward, left and forward. And it is not going beyond a certain limit, starting from its mean position, which is x equals to 0 to whatever value. So, what was the maximum limit? Let's suppose the radius was 10 meters. So, the shadow cannot go beyond 10 meters. Are you understanding?
Yes.
Because the shadow would be, maximum shadow would be here and maximum shadow would be here.
Yeah.
Right? So, that there's a certain limit under which the shadow would be performing the back, forth, and back and forth. This kind of motion. Understood or not?
Yes.
This much you have understood up till now. Next,
Correct.
what happens is now there is a particular thing. Understand? Do you know radians
Yes.
and degrees?
Yeah.
So you have to understand that, see, understand one thing. When I say 1 kilometer and when I say 1,000 meter, so the number, the magnitude of the calc observation or the physical quantity, if it is bigger, you know,
Mhm.
the unit shall be smaller. And if the unit is bigger, the magnitude shall be smaller. See, what is the difference? 1 kilometers and 1,000 meters is exactly the same distance. It would measure exactly from A to B. Let's suppose if I say this is 1 kilometer, but I can say this is 1,000 meters as well, and I can say this is 1 kilometers as well. Are you understanding my point?
Yeah.
Any doubts in this?
No.
So my point is that if I'm calling it as 1 kilometers, right? So what would that mean? Radians and talking about radians.
Mm-hmm.
So you know, if I say pi radians equals to 180 degrees, yes or no? Right?
Yeah.
So there are two units involved here. One is radian and one is degrees.
Yeah.
Now you understand. They're both measuring the same angle. The same distance, the same angle is 180 degrees. The same angle is
Hmm.
pi, 180 pi radian. But what is the
Yeah.
value of pi? 3.14 radian and 180 degrees. So degrees is a unit, but the number here is 180, which is such a big number. So if the number is big, the unit shall be small.
Yeah.
And if the number is small, the unit shall be big. You understand?
Yeah.
Right? So you should be able to convert this degree. So for example, if I told you that, 6 degrees per second, that's the speed, that's the omega. So you will say that, ma'am, if 180 degrees makes pi radians, so 1 degree makes pi over 180 radians. You understand?
Yeah.
Right? So 6 degrees shall make how many radians? Pi over 180 into 6. 6 times 1, 6 times 30. So it shall be pi over 30 radians. So if you
Yeah.
say 6 degrees per second, that is also my angular speed. You understand?
Mm-hmm.
Right? But also 6 degrees per second is also my angular speed, but also pi over 30 radians per second is the same speed. The only difference is that this speed is in radians per second. This is also omega. And this speed is also omega, but that is in degrees per second. Just the unit is different. You understand my point?
Yeah. Yes.
Okay. So, what is the SI unit of omega? What is the SI unit of angular speed? It would be radians per second. Understood or not? So,
Yeah.
you have to express every omega in terms of radians per second. So, thereby, when you do radians per second, so for example, if I ask you that, after 12 seconds, where would you be now? So, what would you do? That, ma'am, after 1 second, I am at pi by 30 radians away from my starting position. So, after 12 seconds, I will be 12 pi by 30 into 12. So my answer shall be what? This is radians per second. This was what? This was radians per second into seconds. You understand? This was
Yeah.
radians per second into seconds. So my the theta would also come in terms of radians. So it
Radiant.
shall become 6 times 2, take 6 times 5. So I would say that, I will be at a distance of 2 over 5 pi radians away from my starting position.
Yeah.
Understood now? Yes or no?
Yes.
This
Yeah.
is the concept. This is the concept.
Okay.
Okay? This is the concept.
Yeah.
So what I'm trying to tell you here is that you have to understand that every omega, every theta has to be in terms of radians and not degrees. Though it is much more easier to understand it in degrees, but we follow radians as a SI system for angle,
Okay.
right? Okay,
Okay.
right. Yeah. So next concept would be, so omega times t would be theta. Unit of omega shall be radians per second. Unit of time would be seconds, and theta would be in radians. And the relation is pi radian. This is how we write c, and that is going to be 180 degrees. Understood or not?
Yeah. Yes.
Okay, that is the concept. Any doubts?
No.
Okay, now just understand. Next topic that you need to know to understand SHM is Hooke's law. Is Hooke's law. Now what does Hooke's law says? Just understand. Hooke's law says that, if for example we have a spring, if for example we have a spring, and this is the box. So the box that is at
Mm-hmm.
t equals to 0 at x equals to 0, isn't it?
Yeah.
And this is the original length of the spring. So what is going to happen? Just tell me. This box actually is going to actually move forward because I'm going to stretch it. So what am I doing? I am applying certain force. This is my applied force. So when I apply it, when I move it forward, so this box basically comes along, this gets stretched up. So the new position would be it stretches up like this, and the same box comes at a little bit forward at the blue position.
Yeah.
But you tell me, the moment you keep applying this applied force, this box
Mm-hmm.
shall remain at its blue position. But the moment you release that force, what is going to happen? This box is going to move back to its original position, isn't it?
It'll go
Back.
in front, right?
Yeah. And once it'll go reach this original position, it is going to compress back and it is going to come here at the red position.
Yeah. Correct.
So what is
Yeah.
happening? When you're pulling it forward, the moment you pull it forward, okay, there develops a restoring force into it. There develops a restoring force in the box. Why? Because that spring is trying to pull it back to the mean position. You understand? So the restoring
Yeah.
force always restoring force develops in any periodic motion, primarily in any SHM. The restoring force develops. You understand?
Yeah.
Okay. So that is the concept of the restoring force. So what do you understand the restoring force? The restoring force is a force which is trying to get back the object to its mean position. That is my restoring. So you see, for example, if you have this pendulum and you push it, so this pendulum goes here. Yes or no?
Yeah.
And when this pendulum goes here, don't you think that it is going to come back also? So what is pulling it back? The gravity. Some component of gravity is going to pull it back. Some
Yeah.
component of its weight is going to pull it back. Are you understanding?
Yes.
And what is going to happen then? You tell me. Then thereby, if the body is trying to move forward, sorry, if the body is trying to move forward, you know, if the body is trying to move forward, there is some restoring force which is going to pull it back. And which is why it is going the other side of the bob and coming back. Because even if the bob is going on the other side, you understand?
Yeah.
This sphere, the blue sphere, is going to come back. And why it is coming back? Because of the restoring force. So the main purpose of the restoring force always is to always bring back, always bring back the object undergoing SHM to its mean position. To its mean position. Are you understanding? Always.
Yeah.
So the because it is a force, right? We call it as restoring force. So restoring force always points towards the mean position. Always points
Point.
towards the mean position. You understand my point, right?
Yeah.
Now you tell me. So for example, in the previous example, if I had this particular spring, so you tell me, this is a box, right? This
Yeah.
is at its starting position at a rest position at x equals to 0. If you pull it forward, little bit, let's suppose you pull it forward from the starting position, you pull it forward by x. Now here you are. So if you are displaced
Mm-hmm.
by a distance x, and let's suppose you must have been here also, there might be a possibility that I pull you more. So
Yeah.
where do you think, in terms of capital X, the restoring force you will experience more, or in terms of small x? When do you feel the more restoring force? When you have just pulled it forward by a little amount, or when you have pulled the box M by more amount?
More.
More. So the moment x increases, the restoring force, you experience more amount of restoring force. That's a very common thing that we generally experience in our day-to-day lives. Even if we take an elastic,
Yeah.
we hold an elastic in our hands, and some other person is pulling it. So we don't expect the person to pull it more, because the moment the person pulls it more, the restoring force is also more and we get hurt harder.
Yeah.
You understand my point? So what I'm
Yes.
trying to tell you, the moment the x, what is x? The displacement from the mean position. What is x? X is the
Display.
displacement from the mean position. So the moment you increase x, the restoring force also increases, but in the opposite direction. Like, for example, if x is here, forward, positive x, so the restoring force would be trying to pulling it back,
Yeah.
right? And if, for example, you are compressing the spring, let's suppose this was the mean position, and you compress the spring from here, you compress the spring to here, you have pushed it backwards by distance x. So the spring is going to like push you forward. The moment you see, this is going to be your applied force. You are applying the
Yeah.
force backward so that the box comes from its yellow position to the red position, isn't it?
Yeah.
And when the box comes from its yellow position to the red position, it is moving back by a distance x. So when it is moving back by a distance x, what would that mean? Tell me. When it is moving back by a distance x, what would that mean? Tell me. The spring is going to push it forward, and the spring will try to come back again to the yellow position. So the displacement is
Yeah.
backward. So the force, the restoring force is forward again towards the mean position, because obviously when it is going to come back again, it is the main position. But I hope you're understanding, the moment the restoring force increases, you understand, when does the restoring
Mm-hmm.
force increases? It increases when the displacement increases. If the displacement is forward, the restoring force is trying to pull it back, so restoring force is here if the displacement is forward, and if the displacement is towards left, the restoring force shall be forward.
Okay.
You understand?
Got
So
it.
what are we going to say?
Yeah.
That force is directly proportional to the displacement, but in a negative direction. So negative sign, how do we say? With a negative sign. So we say F
Negative.
equals to minus of Kx. Understood or no? Any doubts in
Yes.
this?
No.
Right? So this is the concept. Understood or not?
Yes. K is a constant, right?
K is a constant. And here in this example, K could be any constant, right? I would call it as an elastic constant. Or I can also call it as a spring constant. You understand?
Yes.
So F equals to minus Kx.
Ma'am, where will we get the constant from?
I will explain it to you. Don't worry. This constant has a very, very important role in the questions of SHM. So I'm going to come to that. Don't worry about it, because this is a very big topic. But I will have to sort of break it down into small small chunks so that when I consolidate all of them, the picture is clear to you in your mind.
Yeah.
Right. So don't worry about it. This chapter will take little bit like 2 3 classes to come to the main concept. But the moment it is done, the
Yeah.
questions you will feel that okay, how difficult it seems to you, but it is not actually that difficult. Okay.
Yeah.
Understood up till now. Any doubts in this? Just tell me.
No.
Okay. So can I say in this example of the shadow, this is the center and this is the radius r,
Yes.
and the shadow goes here, and maximum the shadow can go up till the red point. So the bob
Yeah.
can go up till the red point, thereby the shadow cannot go beyond the blue point, right? The C point.
Yeah.
So this is it. And the shadow can, the bob can come back at this particular point. So the shadow would thereby come down and the shadow would be maximum at the A point.
Yeah.
So the shadow is actually moving between A and C points. So this maximum distance in between which the bob B is moving, it is
Mm-hmm.
called as the amplitude. It's called as the amplitude of the SHM, the body undergoing SHM. So that means this distance from B to C is called as the amplitude. What is BC? The amplitude. And how do you define amplitude? The largest displacement. The largest displacement of the body undergoing SHM from its mean position. You understand?
Yeah.
ये concept. फंडा समझ आ गया? Any doubts in this? Just tell me.
No.
Right?
Amplitude could be like if we draw the graph,
Yeah,
that will be the height of it, right?
exactly. Exactly. So if we are saying that, the body goes here and comes back, goes here and comes back, so this height is called as amplitude. Understood in this part? Any doubts in this?
No.
Okay. So this is the amplitude.
Yeah.
And at the point C, can you mark the direction of the restoring force? The restoring force shall be maximum here. And at point A, the restoring force shall be here. Why? Because you have
Yeah.
displaced plus x, and here you have displaced yourself minus x. Any doubts in this? So in this example, the amplitude shall be equals to what? Amplitude shall be equals to R, and that amplitude going forward, I will be explaining it as A. Understood or not?
Yes.
Right? So I'll stop my lecture today here, only for 1 hour. Pratiksha, whatever is the
Yes.
next class, whenever is the next class, please schedule it to me, right? And let me know.
Yeah.
Right? All right.
Okay.
Thank you so much. Bye.